Hi everyone, and hello teacher. Today our group is going to talk about Module 18, Cryptography. In this module, we explore how hashing tools are used to make sure that data stays secure, complete, and authentic. In cybersecurity, our group has 4 members, and I'm Nga. Here's how we divide our work. And next, before we start our main content, let's take a quick look at the overview of this module. There are 7 main parts. The first, confidentiality, choosing the right encryption algorithm for different security needs. The second, obscuring data, using different techniques to hide or mask data. The third, integrity, integrity and authenticity, understanding how encryption helps keep data our, or, original and verified. The fourth, using hash, creating hash values and checking file integrity with hashing tools. The fifth, public key cryptography, learning how digital signature work. The sixth, authority and the PKI trust system, using hash to detect any change or attack in the network. And finally, application and parts of cryptography, exploring how cryptography offers of affects cybersecurity today. And the next in Vietnam.
Hi everyone. Today I will talk about Module 18 of Confidentiality. In the module in this in this slide we have to describe about list of the first. There are two classes of encryption used to provide data confidentiality, asymmetric and symmetric. The second, these are two classes differ in how they are used case. The third, symmetric encryption algorithms and data encryption standards, DAS, 3DAS, and advanced encryption standard are based on the premises that each communication party now the pre-share case, and the last, data confidentiality can also be ensured using asymmetric algorithms including drivers, summits, and elements, RSA, and the public key infrastructure. Not DIS is a legacy algorithm and should not be used. 3DIS should be avoided if possible. Uh, the feature highlights some difference between symmetric and asymmetric encryption. Uh, about symmetric encryption, we have to use the same key to encrypt and decrypt data. Uh, Key length are short 40 bits from 40 bits to 256 bits, faster than asymmetric encryption, commonly used for encrypting but later sent out in VPN traffic. Uh, about asymmetric encryption, we have used different key to encrypt and decrypt data, and key length alone from 512 bits to 4096 bits. Computationally facing therefore slower than symmetric encryption, commonly used for quick data transactions such as HTTPS when accessing your bank data. Uh, the symmetric algorithm uses the same free share key to encrypt and decrypt data, and a free share key, free share key stand for secret key is now by the sender and receiver before any encrypted communication can take place. Symmetric encryption algorithms are commonly used with BPM traffic because yeah, they use less CPU resources than asymmetric encryption algorithm, allowing the encryption and decryption of data to be fast when using BPM. When using symmetric encryption algorithm, like any other type of encryption, the longer the key, the longer it will take for someone to discover the keys. Uh, the most encryption keys are between 112 and 256 bits, but to ensure that the encryption is safe, a minimum key length of 128 bits should be used. The symmetric algorithm and recent algorithms are sometimes classified as either block cipher or stream cipher. Uh, about the block cipher, we have to this transform a fixed length block of plain text into common block of ciphertext of 64 or 128 bits. About stream cipher, we have to encrypt plain text one byte or one bit at, at a time and are typically faster than block cipher because data is continually encrypted. Oh, well now symmetric encryption algorithms are displayed in the table. Uh, the left table we have to symmetric encryption algorithm and the right table we have to describe about it. Uh, data encryption standard. The reason legacy symmetric encryption algorithm is use short key that makes it insecure for most current use. 3DAS. The reason the replacement for DAS and repeats the DAS algorithm proceed 3 times. It should be avoided if possible as, as it is scheduled to be retired in 2023. It implemented the very short key lifetime advanced encryption standard. The recent uh, popular and recommended symmetric encryption algorithm is offer combination of 128, 192, or 256 bit key to encrypt 128, 192, or 256 bit longer data block software optimized encryption algorithm. They reason a faster alternative symmetric encryption algorithm to AES. It is a stream cyber that uses 160-bit encryption keys and has a lower impact on the CPU compared to the other software based on algorithm. Rival cipher series algorithm. Several variations have been developed, but RC4 was the most prevalent in use. RC4 is a stream cipher that was used to skew web traffic. It has been found to have multiple vulnerable which have made it in skew. RC4 should not be used. Asymmetric algorithm, public key algorithm are used so that The key used for encryption is different from the key used for decryption. The decryption key cannot, in any reasonable amount of time, be calculated from the encryption key and vice versa. Uh, Asymmetric use the public key and private key, and both keys are capable of the encryption process, but the complementary pair case is required for decryption. The process is also revisable, so the data that encryption with the public key requires the private key to decrypt. Asymmetric algorithms achieve confidently and authentically by using this process. Asymmetric aggression can use key length between 512 to 4096 bits. Key length greater than or equal to 2048 bits can be trusted, while key length of 1024 or shorter are considered insufficient. Examples of protocols that use asymmetric key algorithms include Internet Key Exchange, a functional component of API BM skill socket layer. It is implemented on now as standard transfer layer skill. Skill cell is provided a skill remote access connection to network device. Pretty good privacy. It provides cryptographic privacy and authentication. Asymmetric algorithms are substantially lower than symmetric algorithms, so they are typically use a lower volume size. Cryptographic machines not digital signers and key exchange. However, the key management of symmetric algorithms tend to be simple than symmetric algorithms because usually one of the two decryption and decryption key can be made public. Uh, Define Herman key length 512 1024 2048 37 2 72 uh 4096 division is allowed two parties to agree a case that can use the implement message to what to send to each other. The skill of this item depends on the assumption that it is easy to raise number to certain power, but difficult to compare with power while you are given the number and the outcome. Digital signature standard and digital signature algorithm are 512 to 1024. DAS certified DAS as the algorithm for digital signature. DAS is a public key algorithm based on the signature stream. The signature creates with like but is 10 to 4 times lower verification. Reverse subject and other algorithm 512 to 2048 ISA is a public key cryptography based on the current difficult of patterning very large number is believed to be secure given severely long key and the use of up-to-date implementation. Diagram 512 to 2024 use the public key cryptography based on the HK agreement. It disadvantage is that the encrypted message become very big about twice the size of the original message, and for this reason it is only used for small messages and as 3K and British Cuba technical of 224 or higher. It can be used to adapt many cryptographic algorithms, DH or algorithm. Obviously, items are used to provide community without reset a password. The community object is enabled when the creation process is started with public key. The public key can be summarized using formula public key plus private key equal confidently. When the public key is used to encrypt data, the private key must be used to decrypt data. Only one host has by private key therefore confidently achievable. If the private key comes from another key pair must be generated to replace the compromised key. Example, both and elite data exchange confidently. Elite request is often both public key. Example, both and elite data exchange confidently. Elite use both public key to encrypt the message using agreed upon algorithm. Elite send the encrypt message to both then use this very casual read message. Both is only one the very casually message can only be decrypted by both and thus confidence is achieved. The authentication objective of the semantic algorithm is analytic when the encryption process is started with private key. The process can be summarized using formula private key plus public key for authentication. When the private key is used to encrypt data, the corresponding public key must be used to decrypt it. Only one host has private key, so only that host could have encrypted the message, providing authentication of the sender. When a host successfully decrypts the message using public key, it is just that the private key encrypted the message, which verify who is sender is. Example both and Alice destroy the application. Alice encrypts message using her private key. Alice send the encrypted message to both. Both need to authenticate that message come from Alice. Both request Alice public key to authenticate the message. Both use Alice public key to decrypt the message. Combine the two asymmetric encryption process provide message confidently authentication and integrity in the. For example, a message will spider using both public key and a cipher hash will be encrypted using only private key to provide wider confidently, authenticity, and integrity. Example, both and elite data exchange integrity. Both elite when to send a message to both as well that only both can read document elite when to execute message confidently. Elite use the public keys of both to cipher the message. Only both will be able to decipher it using his private key. Example both elite standard integrated elite also want to execute message authentication and integrity authentication using both that document was sent by elite and integrity ensure that it will not modify. Elite user has her private key to decipher a half of the message. Elite send the encrypted message with the encrypted hash to both. Example one elite data standard ready. What you elite publicly verify that the message will not modify the receiver has equal to equal then the timer has been placed on elite public key. This verifier that elite is the sender of message because nobody else has elite public key. What user his public key to disable the message. And asymmetric mathematical algorithm is allowed to computer to generate an identical set of secret without having communicated before. The nail seller can never actually send between the sender and receiver. However, because both parties know it, it can be used to by an integration algorithm to encrypt traffic between the two systems. Here are two examples of instances when the ACE is commonly used. Data is scanned using an API set BBM ad hoc data is exchanged. As the color feature will be used to steal or complex long number to specify the DRK agreement process. The DSK exchange begin with a link and both agreeing on the arbitrary common color that does not that doesn't need to be kept secret. Below the chosen secret color never to share a list red for So this represents the parity of each party. A league will mix the same set common color of zero with a red color to produce a public color. Or example, we mix the blue to produce a public color of green. Let's send the public color to both and both send the public color green to elite and both it makes the colors the receiver this they out or original secret color red for elite and blue for both. The result is final brown color mixture that identical to partner final color mixture. The brown color represents the result share the secret key between both and elite. The security of the art view a very large double easy classification. It will help on use a different hub group to the my strength of the key that uses the key agreement process. The higher group member is more skilled but requires no time to compute the key. The 41 divided the hub. The group supplied to Seco iOS software and associated prime the number value. The group one the 700 CTI bit, the group 2 1 1024 bit and so on. Next. Watch the video to learn more about cryptography. This lab we have you will complete the following objectives. Part 1 use a classic encryption algorithm. Part 2 use the modern symmetric encryption algorithm. Part 3 use the modern asymmetrical encryption algorithm. This lab we have you will complete the following objectives. Part 1 encrypt the message with OpenATL. Part 2 decrypt the message with OpenATL. And that we have to complete the following objective. Part 1 create and encrypt file. Part 2 recover and encrypt file zip file password. And that we will complete the following objective. Example telnet session with wireless shop. Example SSS hub session. That we have to following objective. Part 1 skill validator, skill validator, skill corporate data between sides.
Hello teacher, hi everyone. My name is Huỳnh Thị Minh Thư and welcome to my presentation. My assignment is about to contain 18.2 data obscuring data and 18.3 integrity and authentication. Starting on 18.2 obscuring data making technique. Data making technologies kill data by replacing sensitive information with non-sensitive version software. The non-sensitive version look and act like the original, so that an originalization process can use non-sensitive data with no change needed to supporting application or data storage facilities. Data masking can replace sensitive data in non-production environment to protect the underlying information. Several data masking techniques can be used. And next slide. The below methods ensure that data remain meaningful but change enough to protect it. The first substitution replace data with authentic looking value to apply anonymity to the data record. And the second shuffling derives a substitution set from the same column of data that the user wants to mask. And the last nulling out applies a null value to a particular field, which completely prevent visibility of the data. Next slide. And the next, steganography, conceal data magic in another file such as the graphic, audio, or video file. The advantage of steganography over cryptography is that the secret magic doesn't attract any special attention. There are several components involved in hiding data. The first, there is a bit data with a secret message. The second, the cover text, and the first, stack key control the hiding process. And the next slide. We have three, that is steganography techniques and social steganography and the last detection. The first steganography technique that is used to aim data in the cover image in using least significant bits. Thick methods yield bit of each bit in the image. The piece in the basic unit of programmable color in the computer image. The second, social steganography in high information in plain sight by creating output can be read a certain way by some to get a secret message based on previously set rule and or identification. In effect, they communicate to different audiences at the same time, sending out two different messages, the apparent message and the secret message. And the last detection. Follow the discovery of the hidden information exists. The goal of a state analyst is to discover this hidden information. Both methods use steganography signature by comparing an original image with the state image. An analyst might pick up a repeated pattern virtually. And the next slide. And the next content is 18.3 integrity and authenticity. The first, security communication. Origination must provide support to secure internal and external traffic. The four elements of secure communication are the first, data integration, and the second, organ authentication, and the third, data confidentiality, and the last, data non-repudiation. Data integration, the message was not altered, and any change to data in transit will be detected. Organ authentication guarantees that the message is not forgery and actually comes from whom itself. Data confidentiality guarantees that on authorized user can be read the message. And the last, the non-repudiation, guarantee the sender cannot repudiate or refute the validity of message sent. Next slide. And the next, that is cryptographic hash function. We have a SIG function. The first, hashing are used to verify and ensure data integrity, and is based on the one way mathematical function, relative easy to compute, but significantly harder to resolve. And the second, the cryptographic hashing function can also be used to verify authentication. And the third, a hash function takes a variable block of binary data message. And the fourth, with hash function is a computationally infeasible for two different sets of data to procedure the same hash output. And the fifth, every time the data is changed or altered. And the last, the cryptographic hash function is applied in many different situations or entity authentication, data integrity, and data authenticity purpose. Next slide. And mathematically, the equal h equal h is used to explain how a hash algorithm operates. A cryptographic hash function should have the following prototypes. That is six prototypes. The input can be any length. The output has the fixed length. H is relatively easy to compute for any given x. H is one way and not reversible. H is collision free, meaning that two different input values with the result in different hash value. Hash to inverse one-way hash means that given a hash value of h, it is computationally infeasible to find an input for it such that h equal ax. Next slide. And the next contains that is NT5 and SGA have function are used to ensure magic integrity that data have not changed accidentally or intentionally. Deliberate change that are made by threat actors are still possible. In the future, the sender is saying $100 money transfer to Alex and want to ensure the message is not accidentally on its way to a receiver. Hashing can be used to detect accidental change, but cannot be used to guard against deliberate change that are made by the threat actor. Therefore, hashing is vulnerable to MITM attack and does not provide security to transmitted data. Next slide. And MD5 and HGA count. There are four well-known hash functions. The first, MD5 with 112A big digits, a one-way function that procedure at 128 big hash message. It is a legacy algorithm and should be avoided. The second HGA1 is a very similar to the MD5 hash function. SGA2 exclude SGA 224. And the first SGI3, the newest hashing algorithm, and an alternative, the eventual replacement for the SGI2 family of hashing algorithm. And next slide. Ring authentication. Use Skyhash message authentication code to add origin authentication and integrity assurance. HMAC hashing algorithm. An AMAC is calculated using any cryptographic algorithm that combine a cryptographic hash function with a secret key. Only the sender and the receiver know the secret key, and if two parties share a secret key and use HMAC function for authentication. And next slide. Creating the HMAC value, the sending device input data, such as Terry Smith pay of $100 and the secret key into the hashing algorithm and calculated the fixed length HMAC targets. The authenticated targets is then attached to the message and sent to receiver. Next slide. Origin authentication can verifying the HMIC value. Therefore, the receiving device removes the targets from message and use the blank text message with secret key as input into same hashing function. If the target that calculated by received device is equal to the target that was sent, additionally, the origin automatic authentication because only the sender processes a copy of the share secret key, and the last the HMS ensure and authenticity of the message. Next slide. Uh, the figure the the figure show how MIC are used basic routers that are configured to use open socket routing authentication. We have one, two, three, and next slide.
I'm Nga and will continue with part 18, 18.4 using hashes. In this part, we see how hashing is actually used to create hash value for files and verify if a file has been trained or not. Next, part 18.5.1 Hashing files and digital media. A hash is used to check data integrity to make sure that the file is still original and has not been modified. For example, when you download software from Cisco official website, you usually give you an empty file or shared hash value. After downloading, you can generate a hash of your file and compare it with Cisco value. If both match, your file is intact and safe. Next, in digital forensics, hashing is also essential. Investigate Investigator never work on the original evidence. They create a bit-for-bit copy and then hash both versions. If the two hash value match, it proves the copy is identical. No data was changed. This principle is called fidelity, er- meaning every bit of data remains unchanged. It helps answer key questions like do do investigators have the exact file they expected? Was any data corrupted or modified? Can they prove that files remain authentic? Next, to part 18.4.3 hashing password. Hashing isn't only for files, it's also used to protect user passwords. When we create an account, the system doesn't store our real password. Instead, it runs a hash algorithm that converts it into a unique hash value, like digital fingerprint. This process is one way. It's impossible to reverse a hash back into the original password. And even a small change, like one letter, cre- creates a complete different hash. When logging in, the system has your input and compare it with the star hash. If both match, login success. So even if hackers steal the database, they only see hash string or not real password. Next, part 18.4.4 Cracking hashes. Now, how do attackers try to break a hash? There are two common methods. Dictionary attack. The attacker the attacker use a list of common passwords, calculate their hash in advance, and look for matches. It's hard if users choose weak password like uh, password or 12345. The second method is proof for attack. The attacker tries every possible combiner, combine, combina- combination of letters, number, and symbol until finding a match. It's always work in theory, but is extremely time consuming. Next, To defend against this attack use long, complex password. When two users have the same password like 12345, their hash will also be identical, which is dangerous. To fix this, we use shorting, adding a random values called short before hashing. Each user gets unique short, so even if two passwords are the same, the hash value is different completely. The system stores both the start and the hash. When verifying, it combines the user short and password again, hashes, and check for a match. The short doesn't need to be secret, but it must be unique and never used. Part 18.4.a. To make this more secure, we use CSPING cryptographically secure shadow random number generator to create unpredictable shorts. And we can add key stretching, meaning hashing or password thousands of times to make cracking slower. Next, to store a password, use CSPING to generate a long random sort. The second adds the short to the beginning of the password, and then hash it with SHA-256, a, a standard cryptography hash function. Save the short and the hash in the user database record. To validate a password, the first retrieve a user short and hash from the database, and the second add the short to the password and hash it with the same hash function. Then compare the start of the password just submitted by the user trying to log in to the one stored in the database. And finally, if the hashes do not match, the, the password the user has just tried to log in with is incorrect. Next, the part 18.4.9 preventing attacks. To make shorting also protects against three major types of attacks. The, the first lookup table, pre-computed password hash pairs. The second, reverse lookup table, using leak hashes to find shared password. And the third is rainbow table, a compressed lookup method. With shorting, all these attacks become useless because every user hash is unique. Next, and I will demonstrate lab hashing everything in the spray video. Next. Now let's move on to part 18.5 Public Key Cryptography. In this section, we will explore digital signature, a real-world application of asymmetric and encryption. Part 18.4 at Part 18.5.1 Using digital signature. A digital signature is a mathematical technique used to ensure authenticity, integrity, and non-repudiation. In simple terms, it's like an electronic version of your handwritten signature. Once document is digitally signed, it become legal proof that the sender is genius and the content hasn't been changed. Digital signature used two key, private key and public key. For example, you sign a document using your private key. Others can verify it using your public key to confirm it's really from you and hasn't been altered. A property of digital signature are authentic. The signature cannot be forged and provide proof that the signer and no one else signed the document. Unalterable. After a document is signed, it cannot be altered. Not reusable. The document signature cannot be transferred to another document. Non-repudiated. The signed document is the same as a physical document because the signature is proof that the document has been signed by the actual person. Next. Digital signatures are commonly used in the following two situations. Code signing is used for data integrity and authentication purposes. It's used to verify the integrity of executable files downloaded from a vendor website. It's also used site digital certificate to authenticate and verify the identity of the site that is sources of the files. Second, digital certificate that are like a virtual ID card and used to authenticate the identity of a system with a vendor website, and is a mechanism of cryptic connection of exchange confidential data. Next, common algorithm for digital signature algorithm. The second is RSA, a widely used asymmetric encryption algorithm. ECDSA is a modern version using elliptic curves, offering faster performance and smaller key size. Next, Part 18.5 Part 2 Code Signing. When we download software like Cisco or Microsoft products, how can we be sure it's genuine and safe? That's what code signing is for. Developers sign your software a digital signature before releasing it. When users install it, the system checks the signature to ensure it's from a trusted public source. The file hasn't been modified. The developer can deny ownership. For example, when Windows shows verified publisher Microsoft Corporation, that's proof of a valid digital signature. Next, Part 18.5.3 Digital Signature for Digital Certificate. A digital certificate is like an electronic ID card used online. It verifies the identity of website, organization, or servers. When you see a lock icon in your browser, it means the site has a valid ASL or TLS certificate. The proves the website is authentic and your connection is encrypted. Let's take an example. Next. When Alice visits Bob's website, her browser checks Bob's digital certificate. If it's valid, the browser retrieves Bob's public key to verify his digital signature. In this image, Bob creates a hash of the message and encrypts it with his private key, then creating a digital signature. Next, Alice received the message and the signature, then decrypt the signature using Bob's public key. She compares the two hashes. If they match, it means the message truly came from Bob and wasn't changed. Next. Now I'd like to invite Jing to continue with the next part.
Okay, hi everyone. I'm Jane and I will talk about the red in the basic way. First, 18.6 Public Key Infrastructure (PKI) Authority in Trust System. Number 1. Public Key Management. Each Internet connection requires public key chains. SSL certificate verify the website identity. Purchase SSL certificate from a trusted provider, CA. CA verify identity before using certificates. Browser check the certificate validity during HTTPS connection. It means when we access an HTTPS website, the browser checks the SSL certificate to verify whether the site is truly trustworthy. This certificate is issued by a trusted third party called a CA. This means Certificate Authority, similar to an identification authority on the Internet. 2. CA act like a licensing authority, link a public key to the owner identity. PKI includes system, tool, and processes for managing digital certificates. The goal is protect digital identity from attack. You can think of the CA like a department of motor vehicle issuing driver licenses. When someone holds a license from the authority, others can track that person's identities. 3. PKI certificate include public key, IUCI information, validity period, signature algorithm. Certificates stored or kept locally. CA sign certificated using its replicate. Its PKI certificate is like an electronic ID card containing the public key, validating date, and information about the using CA. 4. PKI component. 4. PKI components include hardware, software, people, and processes, and so large-scale public key distribution and identification. RA is made Registration Authority Act, delegated CA under root CA. In larger system, RAS assist the root CA in using certificates for small group or organization. Not all PKI certificated are directly received from CA.A. Registration Authority is a subordinate CA and certified by a root CA. And the next, like Bob had a digital certificate issued by a CA. And when Bob communicated with Alice, Alice received Bob's certificate verified with a true CA. This means authenticate Bob identity. And thanks to PKI certificate, Alice can be sure she talking the real Bob, not an imposter. And 6. The PKI authority system. can be outsourced or self-deployed by Microsoft Server and OpenSSL. Certificate are categorized by trust level, validation level, high level, more rigorous verification process. For example, an if is mean extended validation certificate turn the address bar green. It represents the highest trust level. And next, seventh, CI public keys. Some CI public key are preloaded in browser exam, VeriSign, TCSR, and more. Process automatically trust certificate signed IDCAS. When you install a browser, it already contains a directory of trusted CIS, like a global contract list of authentication authority. And the next 8, the PKI trust system symbol model, single root structure, have 3 smart. One root CI ISO certificated for all users. Advantage, simplicity. Disadvantage, difficult to scale. Single point of failure. Did model suit smart organization, but if the root CI fails, the entire trust system collapses. The next 9. Unlinked network PKI may be linked using two basic broad certificate CI topology, as shown in the figure. This is a P2P model in which individual CIS track relationship with other CIS by cross-certifying CI certificated using in either CI domain are also assured that they can track each other. They provide redundancy and eliminate the single point of failure. 10. In this slide, we have both CI ISO certificated to subordinate CIS. Each sub-CI can ISO certificated for its own entities, easier to expand and manage, can combine with cross certification. And we have hybrid PKI. This is the most widely used model today. For example, international CI system use to ISO SSL certificated. And the next 11, PKI different. We have LLS, SSL, TLS, web security, IPsec, VPN, network security, X, MIME, email security, and EAP, TLS, device authentication. And what is problem? Problem is different vendor use different solution, poor compatibility. Because of the lack of universal standard, many PKI systems cannot communicate smoothly with one another. The next 12 slide have IETF introduced RFC 2527 define Internet PKI policy standard X.509v3 International Digital Certificate Format. used in the more modern network system. (13) PKI system must contain the CA public key. Browsers include built-in root CA certificate. Organization apply for certificate insert after verification, and verification may occur out of band. And this process ensures that only legitimate verified organizations are granted digital certificate. And 14. When the certificate fails or expires, it must be revoked. Two main methods. Human method is CRL, certificate revocation list of revoked certificate, and OCSP, online certificate status protocol, direct status vary. Just like when the prior listens for confiscated, the system must notify everyone that the certificate no longer valid. And the last in my video next month in 18.7 application and impact of cryptography. 1. PKI application. Where can business use PKIs? Too much pre-authentication via SSL/TLS, HTTPS, or code signing, and more. When we talk about PKI, public key infrastructure, it's the foundation ensuring security, integrity, and authentication in digital communication. In reality, business can apply PKI in many areas. For example, LLS, TOF, peer authentication in HTTPS website. That's why we see the padlock icon in the address bar. VPN like IPsec use PKI to encrypt traffic over the internet. 2. When discussing encrypted transaction, SSL/TLS is the most common security protocol today. It's modular and flexible, allowing chain algorithm, encryption, integrity check, key exchange, and authentication without designing the protocol. However, encryption also introduced challenges. Traditional security systems can't inspect encrypted traffic. And the next 3. Encrypted network transaction. A common PKI issue is certificate validation. You have probably seen false warning like connection not secure. What happened when LLS, SSL, TLS certificated have problems? For example, the expired certificate outside it, not before or not after. Trigger warning. Sometimes it's just admin oversight, but it could also sign up a browsing risk. Signature validation errors happen when the browser can't verify and certificate authenticity. In the next 4, the figure shows an example of a signature validation error with the Cisco AnyConnect mobility VPN client. Next, 5. With everything encrypted, network monitoring becomes more difficult. Traditional tools only see encrypted data stream, not not the actual content. So security analysts need new approach, identify and separate SSL and non-SSL traffic, UCRL or UCSB to verify server. In short, modern security isn't about locking the door, it's about seeing safely through the door. And final six. Finally, remember that cryptography is never static. An algorithm considered secure today may be broken tomorrow. Cryptography affects security in two ways. Number one, attacker may target the algorithm once decrypt a key or resolvely contact collected data becomes exposed. Two, investigator patronage because encrypted data hide trace and make it incident forensic more complex. Therefore, cybersecurity professionals must deeply understand cryptography, keep up and update, and stay adaptable in the evolving world of digital security. And the next 18.8 Cryptography Summary. Number one, what did I learn from the model? I will show you. I learned about two main types. One, symmetric. Two, asymmetric. The Diffie-Hellman algorithm allows two beta to create a shared circuit without prior exchange. And number two, what did I learn? Two common hack attack, dictionary and brute force. Digital signature. The PKI system it enables organizations to authenticate and encrypt data security on large scale. Number three, what did I learn? I learned something about PKI phase interoperability challenge among different systems, yet its hardwired application SSL, TLS, VPN, secure email, encrypted USBs. Common issues include experience certificated or invalid signature. An encryption suite consists of four elements: MAC, MAC, encryption, key exchange, and authentication. I have relieved that cryptography constantly. So security professionals must continue update the knowledge to counter emerging threats. And that's it. Thanks for listening.